let's kick it off and talk about some of the common problems that we're going to be quickly going over. You already saw some of them throughout the day. Pavneet talked a little bit about, some challenges at scale and with availability. We talked about upgrades and some of the things that we're doing there. So we're going to be trying putting some of the things together. We talked about Istio and fault injection, even though Corey didn't allow me to finish my demo. Because I get to come again, I get to do it again, and we get to finish the demo. And so we're going to see a little bit of the Istio with fault injection and manage Prometheus and Grafana a little bit, and look a little bit into how some of the common application crashes look like. So we saw, on one hand, my AI attempt with KubeCopilot actually produce a pod that was actually on the wrong port. That's actually more common than not, and actually KubeCopilot actually helped us troubleshoot that without having to do a lot of mucking around, but I'm going to cover that scenario here as well. And we're going to talk about, resource contention, kills, a lot of, some of the challenges with network cases like probes or traffic, just not reaching its desired endpoint, or performance, or even some of the issues on upgrades that Alvin mentioned. So let's get started. So kind of a first category of problems is often just my pods are just restarting or non-responsive. Like I keep kicking it and it's still not doing anything. Now, a good way that you're probably going to see everywhere is just, check pod logs, kubectl logs, or some log streaming solution like, Container Insights. Now, one of the things that you'll probably tell me if you're doing this a while is how will I check the logs if the container is restarting like over and over. And so this is true story, won me a bottle of wine. I didn't get the bottle, but someone did the gesture to say they would get me a bottle, which I think makes all it worth it, is kubectl logs-p. So if you don't know, this command might become your best friend because it actually allows you to show the logs from the previous iteration of the pod. So even though it might have crashed, you can actually look at the past in that scenario, and you can actually discover why a pod has restarted without checking its current logs, instead checking its previous direction. Now, a common reason why that might be happening is because the pod might be exceeding its limits. And so in the case of memory, that is typically known as kill or out of memory. And that happens because, in particular in cgroups v1, even though the CPU is kind of a resource that can actually be constrained, meaning that you have resources and you have limits, and you actually, as soon as you get close to the limits, you're actually going to kind of start to get throttled with that CPU. So you're never actually going to get killed because you exceeded or about to exceed your CPU. Just was not going to happen. But with memory, this can actually happen, and this leads to this issue of out-of-memory kills. Now with V2, and if you don't know about cgroups v2, this is something that has just reached stable in Kubernetes 1.25. It is actually the default in operating systems like Ubuntu 22.04 that we have now in AKS. And actually brings some amazing changes. And it is so transformative, so different, so disruptive that it probably warrants its own session, which is actually why it has its own session in KubeCon. So definitely recommend checking it out for those that want to have a deep dive on cgroups v2. But in general, one of the key things that it's going to offer is it's going to actually allow memory to become this kind of constrainable and compactable resource as well, meaning that it will have the chance to act like CPU, in that instead of just getting killed, it's going to start to get throttled as it gets close to the limit. This will allow for, again, just better planning, where today you're basically, the runtime, the container runtime is looking only at the limits. It's going to be able to actually start looking at the requests and limits and map that into an actual min and max in the C group. So this is kind of the future. In the present, kills are still extremely present. And cgroups v1 is still going to be around for a long time. We even have customers and SDKs and runtimes out there, looking at Java, that have a lot of issues with v2. And so that is something that you need to be aware of. Example, SDKs older than like version 8, as an example, in Java actually struggle with v2 still, and with the new mappings. And so a lot of folks are still sticking to v1, which you can just toggle on AKS with a daemon set. But most cases, again, Java, like version 15 and above, and other languages as well, the newest versions are fully compatible with Groups v2, and it has a lot of the goodness that is going to make your life a lot easier by creating less of these problems. Now, one of the things to be aware of that I normally like to call out, though, is often when you get throttled, though, you're often going to create a bottleneck. So one of the things that we actually tell a lot of users that is not super immediate is that a throttled CPU can generate a NUM kill. It's my book, I'm running out of CPU and suddenly I get out of memory. Yeah, because you actually throttle in CPU or even I/O. Like if you throttle in I/O and everything is just continuously getting into the queue and continuously getting throttled, the memory to actually save that in memory is going to be bigger and bigger and bigger until it runs out of memory. So you actually want to make sure that your ratios are appropriate, that your quals guarantees are set appropriately, which again is something that in V2 you can actually do a lot more effectively, whereas in V1 you kind of have this, okay, CPU is compatible, memory is not, I need to kind of be very careful with one in hard line, but then I can be a bit more loose with the other one. You can actually have a lot better control now. All right, so let's stick to where you are right now, I'm assuming. Anybody here already using 1.26 or 1.25 and using 2225? Okay. Anybody gives higher than 25?
If it's available.
Yes, 26 is GA and available, yes. Can you upgrade right now? Yes. Right now, as we're looking at it. Yes. If you have an issue, just bring Alvin back here and then we'll... All right, so in 25 and higher, as I was saying, we actually have 2204. So if you're already in 25, you actually already are using Ubuntu 2204, and you are using already cgroups v2. What about for folks that are not there, or maybe they go there but still can't use cgroups v2? Well, this demo is probably going to be helpful. So this demo is going to walk us through how to actually leverage the Prometheus and Grafana, in the most, I like to call it kind of the most vanilla scenario that you can expect, which is pure monitoring, observability, and troubleshooting. So the first thing that we're going to be doing here is configuring Prometheus. So we're going to create our Azure Monitor workspace. And once our workspace is done and created, we're just going to go ahead and look at our clusters that are available and monitored. So it's just going to list all your clusters. And I'm choosing to do this from the monitor view. You could obviously as well do this from the AKS view and go from clusters and enable monitoring from there. So here I selected our demo cluster, and immediately I'm going to configure Prometheus, and I will select an existing Grafana dashboard. You could also create your own at the time of linking. This is pretty easy and good because you can actually, again, link multiple Prometheus add-on enablements into, obviously, the same Grafana dashboard, which is typically what you'll want for the same environments. And then it's very easy to look at it by clicking on the Link Grafana Workspaces link, and you'll see immediately your one or more, because you can actually pipe to multiple Grafana dashboards, and you'll see immediately that information. Now, an interesting thing that Azure Monitor enables is, obviously you're using Prometheus here, and so typically you'll be using PromQL. Now the question becomes, where are you going to do that? And so there's actually two places where you can be doing this. So you just saw that we linked this to Grafana. So we can actually go ahead and jump into Grafana. Hopefully I didn't break it too bad. There we go. And you can actually see for all these clusters which ones already have it enabled or not, and define again which ones you can, from your unmonitored piece, actually enable the Prometheus and Grafana solution. We're going to go ahead and really quickly go into our demo one. do the same process we just did, but now for this cluster. And we're going to enable Prometheus metrics, send again to our Azure Monitor workspace that we just created, and for our Grafana dashboard that we just created as well. So this is a very similar way for you to do it for just enabling new clusters from your monitor or unmonitored clusters. Once you actually have done this, you can just jump into your monitor clusters and you'll see all this information. This is native from Azure Monitor. And it will tell you again basic information from node CPU, percentage, memory, everything that you need to know. Obviously things like the actual I/O, which are things that we're going to look at afterwards. And now going into our Grafana dashboard. So as I was saying, we can actually have PromQL done in two places in Azure Monitor. You can actually have it within Grafana itself. And you can go and create your queries, add your queries, save your queries, your dashboards, etc. Or if you actually maybe already have everything there and you're in the Azure portal and you just want to run a quick query, you can do the same. You can just select Prometheus as your data source and run a quick PromQL query and see the result right there. So you don't have to jump around for quick operations. You can still keep all your kind of permanent dashboards in Grafana and use all the built-in capabilities as well, as you've seen and you're going to see again for Istio. And still run queries in the place that you desire most. Once this is done, we can actually take a look at in our cluster we have this pet clinic application, and we notice that it's actually reporting no data for memory. In fact, it's reporting nothing. And so that's typically not what a pod should look like. And so that seems peculiar. So we're going to take a look at the namespace pet clinic and see what is going on there. And so in Azure Monitor, we're immediately going to see that there's a warning and that the pod is in crash loop backoff. Unsurprisingly, that's why we didn't see any data. Once we actually hook into live events, and this will keep reporting those live events like with -p, you'll see that there's a backoff and the pod is restarting and the container is failing to start. So one of my favorite things that we just launched in Azure Monitor is the integration with syslogs. So you can actually go into the node syslogs and see all that information in Azure Monitor as well. And so here you'll see that there's actually a number of warnings and even a large number of errors. You can go ahead and filter for those because typically that's where the answer lies when you have this high number, and you see that the kernel is actually reporting quite a high number of errors. Actually plug in before. Lose our presentation here. There we go. Hopefully we're still going. There we go. And if you scroll down, you're actually able to see the raw syslog records. And if you pick one of them, they're all going to say the same thing. You actually look at, hello Java, my old friend, and it's actually being killed. So you can actually now look at this process, you can pass it to your application team, number of things. This is, for a lot of you, actually quick question. How many of you would stop here and just send this to the application team? Good man. Right. So a lot of you did not raise your hands, so I'm assuming that you'd have to continue yourself and actually figure out what's going on. So I'm going to continue this demo, okay? So don't worry about it. But this is typically for a more operation-minded person, where you typically say, okay, I know what's going on. This is application side, running out of memory, Java's being killed there. The main process of the container is being killed. I need to tell the application team to go and fix this. If you are the application team, then oops, you need to fix this. But still, you now know where the problem is, so we're going to pick from here in a second. But before, I actually want to go back in time a little bit into this morning. So for those of you that were not here this morning and might have missed it, we actually announced the public preview of the Istio Service Mesh add-on, and I left the demo halfway, and I never leave demos halfway, so we're going to complete this time around, right? So for those of you that recall, we were enabling Istio, and I'm not going to touch this now because it's not going to allow me to fast forward, so we're just going to quietly watch it again. For folks who were not here in the morning, this is the first time. So reminder, we had basically 3 versions of the reviews. we have a product catalog, we have ratings, we have descriptions. We're deploying all of those services and deployments, again, with pretty standard configuration in terms of ports, in terms of labels, selectors, etc. So we just go ahead and deploy this book info application, confirm that everything is running as expected. And now that all the services and deployments are there we go. We notice that the sidecars have been injected. There's always 2 containers per pod automatically injected into this namespace as per our annotation. And we're actually going to go and add an ingress gateway. Reminder, you can have public and private ingress gateways. So you can have the Istio gateway for ingress control as an ingress controller. So in this case, we selected an external ingress gateway. So this will, as the name kind of indicates, provide external communication, and it will leverage public IPs. Next, we're actually going to apply a gateway class and a virtual service. So we're actually going to start exposing these through our external gateways. And we're going to add our destination rules. So all of them, what is possible, what is not possible, communicating with the backends, with SQL, with everything that needs to be done in order to make those calls possible. And now, because we have several versions, if you look at the pictures at V1, V2, and V3, we're going to make sure that everything is routing to V1. So everything, every service is routing to the version 1 of its service, in particular, the ratings one. All right, so all routes, all traffic, 100% going to V1. We're accessing it, and there we go. Reviews are served by V1. We have book reviews there. We have book details. Sounds good. Now, when you enable the Manage Prometheus add-on, this is yet another one that's where we stopped before. So this is uncharted territory now. You're actually going to get a lot of the built-in goodness of Manage Prometheus and Grafana and get all of this that you typically have to deploy. It's also not that hard. You can go online, find these pre-built dashboards and deploy them, but this is going to come out of the box for you in Manage Prometheus and Grafana. And you're going to be able to see, the duration, the latency of the requests, how many are being done, the timeouts, success rates, all the things that you expect to see, and you can, circle through all of them. So we can go into the details, and you see the duration of each request. Seems decent, nothing too surprising. You see that there's encryption there, mutual TLS going on. And you notice that we actually have the 3 reviews piece. So we're checking V1, all looks fine, 4 milliseconds, nothing too surprising. So take a look at V2. Now this one has a bit less data, right? So because we didn't really send anything there. So that's kind of expected. V3, same thing. We were routing everything to V1. So this is kind of the magician saying no tricks. So everything is going to V1 right now. No data shown here. No packets being sent. Expected. So let's now change this. So 50% of the requests sent to V2, and we're injecting fault. In this case, we're doing a delay of 7 seconds. Now, you're going to trust me when I tell you that that's too much, because our timeout is actually smaller. It's actually bigger. And so when you put that, you're actually, and let's access the web page now, that we injected this 7-second delay, and there you go, reviews blew up. So we injected the fault, success, we broke it. Let's try and go and fix it. So it timed out at 6 seconds. We had a fault of 7 seconds, so naturally it didn't return. All right. So we can actually now come into Grafana, actually take a look at what happened, and now that we have multiple services, you can actually navigate to them, and we know, because I injected the fault, but if you didn't, this is where you would actually find out where exactly the bottleneck happened, where did the delay exactly happened, and you could skim through it. So in this case, you could spend some time on the product. You saw that it delayed a bit, but that was not what the biggest time was. Interesting, 5 seconds, 4 seconds, okay. I think I know where this is going. I think I know where the problem is at this point. This time is huge. So the timeout is too long. It's 10 seconds, and it took our 7 seconds. So we blew up. We need to reduce this. So that's basically what V2 does. It reduces that timeout so that the retry happens and you actually are able to show the right information even with this fault injection. So let's actually do that, and let's make sure that we replace this. So we update this to V3, has a 2-second timeout. Now it's slower. Let's get that going. And once we actually access the application again, now leveraging V3. There you go. Reviews are back up, but ratings is still down. So now we can continue to kind of troubleshoot and say, okay, we fixed this one. Guess what's going to happen? Ratings also has the timeout is not appropriate, so we would go and do the same thing and fix ratings, but reviews are already fixed. So this is an example of how you can actually use two things, or three. How you can actually use the issue service mesh add-on. Some of the goodness that you get by having the add-on, which is just the out-of-the-box monitoring and metrics offered by Azure Monitor, and then also how you can leverage things like fault injection, issue feature, as well as the capabilities of Azure Monitor, Prometheus, and Grafana to troubleshoot what happened, where delay happened, and where latency is happening. All right, let's get back on track now that you saw the demo, and I'm vindicated. So what if your pod really, really, really is getting annoying, and maybe it's a little bit not as obvious as before? So there's too many examples, so I'm just going to simplify it because it's the end of the day. A simple case is, okay, the pod itself is restarting. And this is not with me, but I believe Patrick Healy in my team actually stumbled upon a case with a customer where he saw something along the lines of 46 million restarts happening. And there was a question from the user on why there was some problem. If you fix that, things do tend to improve in terms of performance. Okay, this is when the actual process restarts and the container restarts because of it. But it's not always that obvious. And for single process containers, this is actually pretty easy usually, because restart means that process failed and you can clearly see it. You see it on the state of the pod. You see it very clearly. In other cases, the pod is running, seemingly happy, and things are just breaking left and right. And that's the second case that I show here, where actually there's 5 processes in this Python piece of code, and you actually get several of those processes, of those threads, killed. Not all, just several. And so this is going to produce all kinds of different results. And by the way, oftentimes for migrations, as you're coming from, say, a VM or a traditional environment, just something not in Kubernetes or not in containers even, this is usually where folks start to find problems that take a lot of time to debug. Because, oh, this just used to work fine. Yeah, because it worked in a non-constrained environment. Now you're constraining memory aggressively in cgroup v1. And so these threads are being killed. And then your code might be doing the right thing. You know, it's going again and again and again, but it's taking way longer than it used to for the same hardware. So do take a look at this. And this is why, again, hooking up the right monitoring and having the right alerting is important, because you'll see this as well. You'll see it per thread. Oh, why is these threads, erroring out? Why is this taking longer specifically? And you can see, oh, actually, if I just bump the memory up, this just goes exactly at the same speed that it used to. Other cases that we see for this is when the infrastructure itself and the system part itself starts to get impacted. There are several cases, as an example, that are not constrained as such for C groups. And so you can actually create yourself problems when you start to become your own noisy neighbor. And you start to do things like assume core DNS. That's your DNS server. If you create a noisy neighbor issue to your own DNS server, you can blame DNS because it is always DNS, but it's actually your fault. So we recommend, it's in our documentation, to have separate user pools, separate system pools, so that you avoid your own set of noisy neighbor issues to DNS and to other cases. The use of pod affinity, the use of taints, specifically the critical add-ons only taint, that all the system components tolerate. Is this always needed? Well, there's nuance. They're called best practices for a reason, and every environment is slightly different. But it is a guarantee of success versus not using it. So if you're not using this, you really need to know exactly what you're doing and how you're avoiding that, especially in terms of things that are not constrained by secret. I/O is a great example as well. Network throughput is a great example as well, which again affects DNS quite a lot. We are scaling these components. We are spreading them across. But if you max out the infrastructure where there are, that will cause problems. All right. Alvin talked a lot about what we're doing in this case, how we're trying to make sure that apps don't crash when you upgrade, how we're putting things like the automatic detection of breaking changes, so that even if you're have an operator or a controller and it's in code, that version, we're still detecting, we're still stopping the upgrade. We are able to tell you specifically which verb, which user agent has that deprecate API. We're doing all kinds of validations, from quota to IPs. We introduced a number of improvements on the networking side to, for example, you don't run out of IPs that easily. You can use overlay and really go big and extend your clusters. But if at the end of the day you don't put a PDB and all your applications can be restarted, all your replicas can be restarted at the same time, kind of all for naught. And while this might be a roll's eyes moment, I think there isn't a day that goes by that we don't find a case that was caused by a PDB either lacking or being misconfigured. Because of this, we're actually about to launch several features that help you set up PDBs and do so automatically as well for you. Because one, you need to set them. You need to put PDB so that if you're not familiar, so that your pod's replica number is actually the minimum that you need. And so in Alvin's case, as you saw before, he had a minimum baseline of like 15 or something. So you could keep the minimum traffic available and keep the requests per second to a sustainable rate without hurting its users, and doing so during an upgrade. So this is the kind of thing that you can do with PDBs. It doesn't go just beyond problems. It's also about, okay, I want to be sure that when I upgrade, maybe it takes another hour, maybe it takes another 3 hours, that's fine. But my requests per second, my user experience is going to keep consistent. So setting them, very important, setting them with good values that look at your baseline. So use things as we did in that demo, and use things like Azure load testing or Azure chaos testing to actually ensure that you're testing for those real scenarios and not just, okay, PDB, the most harmless PDB to put is minimum replica 1. That's the one that pretty much everything should have, except one case, which is a deployment of replica 1. Because in that case, you're going to enter that log and it's not going to continue. And we're going to stop the upgrade in those cases because we have no way to do that without violating that PDB. So we're not going to proceed. But every other case, that's a very minimum. Doesn't mean it's the right one. So please do some load testing, do some chaos testing, and ensure that you have the right PDBs for your deployments. I already discussed a little bit about the noisy neighbor issue with system components. It's also particularly hard to spot on for things that are not clearly in when you describe a pod or when you put the logs of a pod right there. And those are the cases for things like network, throughput, I/O, disk throughput. And those things are shared, and they're not independent. And they throttle. And as we saw before, that throttling can cause all kinds of issues. Moreover, things like on the storage side, you have, in some cases, different limits. And you have a Venn diagram between both of them. So you might have a VM that supports, say, 80,000 IOPS. Great. You're doing a great job at selecting a SKU that you use. However, you're using a 2 gig disk that allows you for 500. So guess what? You have 500, not 80,000. Today, AKS will default into a ephemeral OS, which is basically a local disk for the OS system, because the OS system is really where a lot of the issues in this area come in, because everything from the container root file system to ephemeral volumes all come from there. So things like loggers love these ephemeral volumes, love this root partition, and we'll be writing a lot, and it will start to affect everything else. If you put a bunch more applications doing the same in a disk that doesn't have a lot of I/O, you're going to struggle really quickly. And the way it manifests and has consequences is not always obvious. It might be application number one performance that is going to be affected. And you're going to have to spend some time going through the rabbit holes in order to get there first. So because of it, we actually are defaulting to ephemeral OS, which gives you the best performance possible for the SKUs that support ephemeral OS. So we're going to put the operating system in a local disk that has the highest performance possible. And it's literally local to that VM. And it also happens to be free. This doesn't meet all use cases, naturally. And so you can use managed disks. Just make sure that you are setting up the correct OS disk size and tier for it. Make sure that you are allowing things like bursting, and that your caching for reads and writes is appropriate to what you're doing there. So when you're selecting, and I'm going to let you read this slide. Yeah, take your time. Some time to drink water. All right, so to recap, you got this. You selected a big disk, high IOPS, but then you went on and selected the D4. Now you're limited by the VM itself. So you need to always consider the Venn diagram. You selected D4 instead of D4S. Now you don't have premium storage. So you're running in either HDDs or standard SSDs. Problem. You might need more. You might even need Ultra, which we make available. So always make sure to match these things. The case of DDS4, an important case, because it has the local disk, whereas the V4 and V5 generations no longer have the local disk in the standard versions, only in the D versions. So if you're really interested in geeking out where these names come from and how we actually look like we fall onto the keyboard and create a SKU name, there is a logic to it. It is on top. So it's typically going to be family, subfamily, then the actual number of CPUs aligned, so alliance of 4 CPUs, and any constrained CPUs, and then features, additive. Like the D, for example, is that local storage as an example. An A will typically represent AMD CPUs, and so on and so forth. How do I detect that then? Maybe I know that I should be careful with it, but how do I know if I'm actually at the limit or not? Where you can actually look at what we just enabled before and take a look at, for example, the queue depth. It's not a guarantee. You're going to see better things in a second, but this will tell you right away if it's something you should be looking at. If it's non-existent, then yeah, probably you're fine. If it's high, you should probably be paying closer attention into I/O, because you might be being constrained by it. Let's go a little bit into networking and what happens when your traffic, app to app, inside to your app, whatever it might be, doesn't work correctly. It could be a number of different reasons. It could be, the selector is wrong. A penny for every time I did a type on the selectors. It could be, as an example, the exact issue that we found this morning. Again, for you that were not here this morning, probably good to review the keynote. We had a demo there where we actually, via AI and Copilot, actually created a deployment automatically that just did its best and mapped to 8080. However, the container port was 3000. So it's exactly this common case. And Kube Copilot helped us troubleshoot it. And then probes, which is like a little bit like PTBs. Everyone knows that they have it, but they're often also sometimes the cause of problems themselves. It's important to understand that there's three main types of probes. Two until recently, the liveness and readiness probes. The liveness probe is really all about the pod needs to be restarted. Like it's like a permanent failure, it needs to be restarted. The readiness probes is the pod is running, but it's not ready to receive traffic. An example of where this could happen is a transient failure. So this is key distinction of how to use and where to use each one of these. Startup probes come in because if you're doing really good probes, and that apparently only happened recently, and when people really started going aggressively on doing really good granular probes, they found out deadlocks where the pod start took so long that the probes hit their own timeouts and then started to do things like restarting the pod. And so the pod would never come up because the time it took hit the liveness probe and it would go restart again and restart again and restart again. And so use startup probes for this to ensure that your app is appropriately tuned for your probes. Your probes might be fine. Don't tweak your liveness and readiness probes because of your startup time. Use startup probes instead. And then have your, again, a penny for each one, have your readiness probe check more than just if the port is open. Because if your application has 5 connections, and again, we just saw an example with Bookstore, etc., and you can't connect to the DB, great, the port is open, and so what? So you shouldn't be receiving traffic in that replica anyway. One thing that I think is the underdog of describes is service describe. I always liked it. I'm traditional that way. And I think it provides a lot of underrated information. The endpoints, the port, for example. If I did describe to my service before in that demo, I would have actually seen several things, like the target port, node port, the endpoints, what they're exposing. Are all my endpoints that I expect listed there? Are they not? What kind of cluster do I have? Is it a single stack, dual stack? It's going to have additional implications. The next thing that is a common problem is the case of snap port exhaustion. Who here has hit snap port exhaustion before? 1 hand, 2 hand, 3 hand, 4 hand, okay. Are the rest of you shy? Okay, more hands coming up, okay. So it's a bit of AKS's fault, so we apologize for that, because the fact is, the way that the Azure Load Balancer works is it's going to try its best to provide you with those snatting capabilities. And the default for that, I mean, each IP is going to have 64,000 ports available to it. So when you have the load balancer with its outbound IP, you can basically distribute those 64,000 across the cluster, all the nodes that it's going to have. What's the right number? Well, it's a bit hard to know when you have the static assignment, which is what the load balancer has, because it's doing that kind of as a best effort. It's not a natting, service per se. And so it has this algorithm that you see on the left-hand side that is documented, where depending on the node count, the number of ports available is going to decrease, because again, you only have 64,000. So if you keep increasing, you can't just keep it at 1,024. So this is the first place where you can usually trip. Now, it can be easy fixes, like increasing a few more nodes for quick mitigations, but really, the more correct mitigations is A, using something like managed NAT. In managed NAT, you no longer have kind of this static assignment. You actually have pretty much the 60,000 ports available to all the nodes at all times. So if the port is free, it can be used by a node, any node, and once it's done, then it's done. So you can always have, basically, regardless of the number of nodes, you can always have the 64,000 connections per IP to the same destination. So it improves that by quite a lot. And if you need more, you add more IPs. So the recommendation here is really to just use managed NAT when you have the expectation of a lot of outbound connections. some cases, you might even pass on the 16 or the maximum of managed NAT, and we do have cases for those as well. Sometimes you might want to bypass load balancers and go out directly, and you can have a public IP per node that will basically use that IP for ingress and egress if you want. So that's also an option. All right, I promise you kind of a quick primer of the tools that we have and what's coming. I showed you already Azure Monitor, Prometheus, and Grafana. Let's take a look at 3 other cases and what they're for. Where do they sit? How do they play together? So the first one is cluster diagnostic settings. This is basically all the control plane monitoring and logging. So you can have things like, as you see there, the API server, controller manager, the scheduler, cluster autoscaler. You can see the logs for all the components we have and manage for you. So you can debug, troubleshoot, and understand the behavior of anything. And complain at us. Yes, do complain at us if you see something there that shouldn't be there and looks off. You can also choose where to send this. This is important, especially on audit logs. Common case, you need to know who did what, when. So that's really what audit logs is for. However, often cases, audit logs is extremely verbose because, again, it literally logs everything that happens at all times. We provided a category that is more, let's say, cost-friendly, which is what you see there as audit admin logs. Those are typically what you would call the writes. There's no real concept of writes, but there's these admin operations, like a write. And so we're logging those instead of all the gets that all the controllers and system are doing in those cases. So you can enable those, and those are better for if you actually have a lot of needs. What we typically see from a lot of our users, however, is that they're sending their, let's say, API server or scheduler logs into log analytics so that you can go and with GraphQL actually query them and do all kinds of queries, debugging. And then they're sending their audit logs into storage, so cold storage, so that it's cheap and it serves more purposes of auditing. So they're not as easy to query and as easy to use, but they're available for any audit purposes. The other one is Periscope. So Periscope is, in essence, a tool that was created with the objective of making your support experience, when you, for example, pick up the phone and call Microsoft or open a ticket or go to the portal, just easier. So the way that it works is the support engineer is able to tell you to run Periscope and update and upload the results. So it basically takes a snapshot of your cluster with a lot of these information, IP tables, the connections that were happening, the state, does it connect to ACR, can it connect to the API server? So just a snapshot of the cluster, and then you upload it to whatever location you want, like a storage account, and then you can or not provide that to support. Typically, that's what you would do. Now, we found that this, on one hand, we actually built a lot of this tooling internally, so we don't have to ask it, because I think better than asking is for us to just do it. But there's actually other use cases. And so potentially several of you here might be managing clusters on behalf and might be actually servicing those clusters. And so a lot of our partners, a lot of our managed service providers actually use this themselves because they are the actual DRIs and support engineers and SREs for their customers and their users. And so they use Periscope to actually do that. So while we actually have a lot of this information that you see here now actually internally, we continue to extend it to ensure that both us and service providers are able to actually support those clusters. Now, the key thing for Periscope, though, is it takes a snapshot of the cluster. And that's really its purpose. Right? So it's not Azure Monitor. Hopefully it was clear. It's not taking a snapshot of, or giving you the logs, stream logs of the control plane, that was diagnostic settings. It's taking a snapshot of this, so the IP tables, what's your network configuration, the state of your nodes. That's what it basically takes. Next, we have something interesting that maybe a lot of you know. Some of you, anybody was at Rejects yesterday? One person. All right. Is that you, Pavneet? Okay, fine. So nobody was there. Yesterday at Rejects, we actually got a presentation on Inspector Gadgets, why I was asking. And so Inspector Gadgets is actually a project that has just entered I think it's either entering Sandbox We're about to enter Sandbox, and it's in the donation process. It was created by a company previously known as Kinvolk. They became part of Microsoft basically now over a year ago. And it basically leverages BPF programs, so-called gadgets, to actually intercept calls to the kernel in a similar way that Cilium, for those of you that are using that, does for proper auditing and routing, etc. In this case, it's for actually troubleshooting purposes. So the way it kind of simply works is you have your command line, your kubectl gadget, and you call the API server, and then there's a component in each node that is going to be taking care of this connection, intercepting those calls, and producing that data back, all the way back into the user. Better to look at it. So I mentioned that there was a better, easier way to actually look at things like, okay, who is actually causing the noisy neighbors in a storage situation? So a good example of that is gadget top block IO. And it literally points to the culprits immediately. So in this case, literally what's happening here is I'm using FIO to literally just overload a small node with a small disk. So I'm being bad on purpose. But nonetheless, the goal there is you're going to be and this is basically like top nodes. If you're using kubectl top nodes, it's exactly the same. So it's going to continue to update as you'd expect as it progresses. So it's no longer a snapshot. This is actually streaming at this point. And similarly, you can see, connections. So if you have a bunch of connections happening and you're trying to figure out what's going on with your, the number of connections as we just saw, or your bandwidth or what's going on, you can use top TCP. And similarly, you can use top file, for file I/O specifically. This is kind of what the top command does. There's more. There's commands like trace, where you can actually, run traces to network, and it will be smart enough to, pick up things like to pick up. Actually, I just found an interesting thing with this image. So it will do very interesting things such as updating things like calling 53. You could just put the IP afterwards and the endpoint, but actually knows that that's core DNS in this case, or the kubedns service, so it just updated to there. So you can very easily read through that on the ones that are being done, and again, every new one is going to be added into it. And you can take a look, okay, so I have some outgoings, some ingoings, some TCP, some UDP, what are the ports? You can just list all those connections. I didn't ask you in the previous one because it's a lot more convoluted what the issue was, but anybody can tell me what the issue is with the AKS day application here? Hopefully you can see well at the back, but if not, I'm going to quickly reveal the solution. Can you see, Corey? Okay. Can you say what the issue is anyway? Just guess. Any guess? Fun part is we have the most brilliant minds of Azure networking here, so I'm duly expecting that they're just quiet. So the actual easier answer is right here. We're actually connecting to local hosts. So if you're actually going out, so this is going nowhere. So if you're actually going out, you should have something like 0000. Otherwise, this is not going to do anything. And similarly, if you had something like, and this is a common problem as well that we see, especially for the warriors embarking on IPv6, where you go and you look at this, and this shows 000, and you're like, this is good, moving on. That's just for IPv4. You actually need to have both mapped there if you're doing IPv6. But yeah, you can trace this. So in this case, kills as well. I told you I could provide you better information. So you can actually see with trace kill exactly where the kills happen, what thread they happen, when they happen, what page file they had. You can see all the information you need in order for you now as an application developer, or I don't know how folks call themselves these days, but in your day job, doing what you do, you can actually fix this problem. There's many other commands, and so I'm not going to go through all of them. Again, definitely recommend the reject stocks from yesterday. But just a quick overview. Aside from top and trace that we did see, you can also take snapshots. You can do audits. You can also get advisory, so you can actually do recommendations for all kinds of best practices and recommendations like network policies as an example. Okay, what kind of network policies do I need? So you can actually inspect the traffic and say, hey, you have 1 connecting to 2 and 2 connecting to 3. 1 does not connect to 3. Maybe you should put a network policy. And it can also tell you the opposite. Oh, you're thinking of network policy 2 and 3. They are making connections. Just FYI, you could probably look at that first before blocking it. So it will tell you all that information. I'm not done, even though Corey really wants me to be done. So some pain points remain. Namely, if you notice here, this is literally, we got to the tip of network observability, and it's still very streaming. And if you got back, I went into the BPF rabbit hole with Inspector Gadget, and I kind of stayed there. But that's not all the data planes that we have. That's not all the architectures that we have. We have Windows, we have Ubuntu, Mariner, we have eBPF data planes, IP tables data planes, and we want to make sure that you have the same experience across the board for everything. And so we designed this project called CAPI to offer eBPF-based networking observability in eBPF environments, to build on top of all the tools, you see several already here, like the Cilium plugins with eBPF, or even bring your own plugin, and to serve as a platform for you to hook in any monitoring observability tool. So yes, everything that I just showed before, you can use it with CAPI, and CAPI will provide you a lot more richer data for all of your environments. It also can be cloud agnostic, and it's going to be architecture and platform agnostic. How? Well, you're going to be able to, or CAPI is going to be able to, basically hook into the best of breed for every single platform. So if you have a cluster with eBPF and Cilium data plane, CAPI is going to hook up directly, and it's going to expose and provide all of that information. You can then surface that with things like Prometheus and Grafana. If you're a Cilium user, maybe you're using Hubble. So Hubble, if you're using something else, you can use something else. But that might not be all your cluster. Your cluster might have, or that might not be all your environment. You might have IP tables environments. So what do you do now? So CAPI actually can extend even non-Cilium environments and leverage Inspector Gadget that I just showed you, because we are installing all those BPF programs, all those gadgets, and all those capabilities into every node that we have for Linux, and expose those back up. And moreover, even Windows that has its own programs, its own modules, its own kernel, and does not have eBPF, but does have pretty lengthy and large support. It's just not as common in the container world. CAPI is going to make that available and exposed, so you can have the exact same experience across all platforms. How does that look like? So in a cluster where you have, as you see essentially at the top, 3 versions: Ubuntu, Windows 2019, and Windows 2022, just to make it hard, extra hard. We have the CAPI agent collecting on all 3. And we have our applications here just generating traffic. And we also have a deny all, just to make sure that everybody's fighting against everybody, nobody can talk to anybody. So everything's just broken. We also have, as you see by the get pogs on AMA, that we have Prometheus and Grafana installed. So guess what? We're going to get a lot of that goodness and good magic again that we saw with Istio. So let's jump into that. So as you actually move into our Grafana dashboard, so again, Prometheus and CAPI are, CAPI is exposing that as the platform, Prometheus is collecting all of that, and then Grafana is displaying it. You can actually see very, very rich information that I haven't showed you before. You can see, the bytes per second, you can see the dropped bytes, you can see the throughput total, you can see how many are being transmitted, You can see the stats, for TCP, by UDP, by all kinds of statistics, all the state, by the address, by endpoints. You can do everything that you can imagine possible through this. And you actually notice, if you notice from there, that we actually have quite a few packets being dropped. Again, no surprise there, because we're pretty much making them drop all over the place. And again, you can use the same capabilities of Grafana that you expect. And for other tools, same thing. Oh no, this is Corey. She's making me leave. All right, stabilized, very good. So you can see further data for like interfaces, the actual network interfaces, what data is coming from there, the drop count, as you see, just going up, 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 and up. And at this point, you might be like, okay, I detected a problem. How do I look further? So you can actually do a capture with Cappy. In this case, we're setting it for 15 seconds. Again, we did pretty much nothing. I didn't give you a pod. It's just my application, and the rest is AKS tools. And you went ahead, you run that capture, and if you do that streaming, you can see that, or you can actually save that to a file, and then you're going to go ahead and open it up, open your packet capture file. There we go. And you're going to be able to see that, again, across any platform that you want. Windows, Ubuntu, Mariner, whatever it might be. This is where I finish.